Next we are going to see about the metastability concept. Okay, so when this metastability concept will come into the picture, if your circuit doesn't satisfy setup time and hold time, then we will get your circuit will fall into this metastable state, right? So asynchronous input, consider this one. Digital systems of all types must deal with asynchronous input signals that are not synchronous with the system clock. Look at this. A synchronizer samples an asynchronous input and produces an output that meets the setup and hold times required in a synchronous system. For example, consider two blocks. Two blocks are working under different frequencies. Okay, so first block is working at the frequency of x. Second block is working at the frequency of y. Now the data transaction is happening between these two blocks. Now definitely there will be a synchronizing problem. So in between that those two blocks, we have to insert a synchronizer logic so that it will produce a input signal in such a way that it will satisfy the setup time and hold time of the second block, right? It is very easy to build a synchronizer if we ignore the problem of metastability. Consider here, look at this slide. D-flop samples the asynchronous inputs at each clock tick of the system clock and produces a synchronous output that is valid during the subsequent clock period. Look at here, this is a system clock. Okay, here we are getting the asynchronous input. Okay, so this input is sampled here. This is a passage of clock. During this passage of clock, what is the input? Low, right? That's why it has sampled that input signal. That's why it is maintaining the same level. What it has sampled here? 0, right? So that's why it is maintaining that output as 0 up to here. In the next passage of clock, what it is doing? Again it is sampling. So here what it is receiving? Logic level 1. So that's why it is maintaining logic level 1 for next clock cycle. But look at here, what's happening? Here logic 0, right? It's maintaining. So this is an D-flop clock and synchronous system. Okay, so this synchronizer is making an asynchronous signal to a synchronized signal. This is called synchronizer logic. Okay. Yeah. Even synchronizer can sometimes fail. The reason they do is that the setup and hold times of synchronizing flops are sometimes violated because the asynchronous input can change at any time. Getting look at here. This is a clock.
It or may not take it.
If it will take it, it will give output.
If it will take it, it will give the output. If it misses it, then there is a probability that it will take the previous state and continue up till the next clock edge, and at the next clock edge, it will detect what is present, which has changed. Like if previously it was 0 and it is now 1, it may take capture at the next.
Okay, now come to the case that if it is taking it and it is giving actual output, can we consider this case as the negative setup case?
No.
Why?
Negative setup case.
Since the input is changing.
You observe the definition of negative setup case. What is negative setup case? See, wait. Negative setup case is after the clock edge also. The input may change and still it may be recognized. Now before the clock edge only it is changing.
But it is inside the setup window, na?
Huh?
That's what I am asking. Can we consider
it? Is not in setup window. After the clock edge it is not in setup window. It is in hold window.
Before it is here changing before the positive edge, na? And still it is giving output.
Yeah.
But it is changing inside the setup window. So this case is not means negative setup time means only in case of hold time. Is it like that?
Yeah. What is the definition of negative setup time after the clock edge?
Yeah.
the input may change and still it may be recognized. Okay.
So it is exactly after the clock edge.
Yeah.
Whether it may be before the clock edge and inside setup window, that is not considered as negative.
Okay.
Yeah.
So far
This
whatever
is the setup time and
whatever
hold
the
time is
things
a
we have
different.
discussed, that only here mentioned, right? And the synchronizer failure is said to occur if the system uses the synchronizer output